Hello everyone, and we're back. So Lee, in the last video, said we're going to optimize this. How so?
Yeah, well, I've got this whole other way of doing bit shifting, does some really cool things and throws some numbers around that, gives us a much more optimized number. At least that's what I thought. At the end of the last video, one of the things that I had implemented was this fractional part. And then I was showing this little trick that where you multiply it by a fraction and then multiply it back in to get even more accuracy. Well, the funny thing is this was a trick that I developed when I was trying to optimize the optimized version
Mm-hmm.
because this one before I had this trick wasn't quite that optimal. So if I go back to this part and I build it out, well, that's really bad now. So apparently we've only got one unique number, but that's because I had summation there instead of product. Okay, so
You mean you had product instead of summation? Wait, hang on. Am I
no,
seeing
when
things?
I no, it's a summation now, but
Right.
I had changed it because when we had zero, it was because I had a product instead
Right.
of the sum.
I thought you'd said it in reverse order. Okay, anyways.
Okay, so I was getting this type of result after doing this optimization,
Mm-hmm.
which is what prompted me to go in and optimize a new system or come up with a new system that was more optimized than this. And then I had created one. And I further refined it and further refined it. And I got down to about 19,500 duplicates.
Mm-hmm.
Well, one of the tricks that I had, um, still running, one of the tricks that I had done after optimizing it, the new procedure without this particular trick runs at about 200,000 duplicates, which was better, but still not good enough. So what I came up with was this as a means to further refine it to get a little bit more or less duplicates,
Mm-hmm.
as it were. As it were. So in the last video, I had implemented that trick into here, but what it ended up doing is pushing my duplicate count to just over 14,000, which is better than the best optimization that I could get with the optimized version of this method.
Gotcha.
So the one of the things that, it's kind of cool is happy accidents every once in a while because I'm literally changing this stuff on the fly
Mm-hmm.
as I'm coding this for the video as opposed to my notes.
Right, right.
So I had changed that up and it turns out we end up with something better than we had before. So we're not going to optimize hash 2. Matter of fact, I'm going to take my optimized version that I've got, throw it away in favor of this version.
Okay.
So, but what we will do in this video is make a 3D version of this hash. So
Okay.
we're going to duplicate the 2D version. We're going to paste it. We're going to rename this hash 3D. We're going to take in a third float being Z or Z. Duplicate this one. Paste it. Change this to UZ. Change this the Z and this one to Z. And then we'll add this up here as well. So plus UZ times, just another prime number off the top of my head. Let's go with 283. No, actually, I've got a table of primes off to my left. So be kind of cool if you could rattle off the primes like that.
Some
Sounds like,
people can.
yeah, I can't. So I can't even speak words that have more than 5 letters in it sometimes. All right, so now we've got a hash 3D. So pretty much the same as hash 2D. We're just adding in that extra argument. Let's go up here. comment out that one, duplicate it, paste it. Now, in this case, I'm going to go with, let's do x times y times 0.1 float. So we can get something different without having to go through and add in another loop. And still make it not happy.
Well,
Oh,
first thing you need to
hash
change that to
3D.
3D. Okay.
There we go. Well, not first. That's the only thing I had to
Now
do.
you need to test it. Second thing.
No, it's going to work great. No explosions. Look at that. Only 831 duplicates.
Not bad.
Yeah. So if I were to run the same thing, you guys won't be able to see this one on mine, unfortunately. But if I run the same variation with my super Wampidine optimized one, let's see what we end up with. So use the same one there. My super optimized Wampidine comes up with 20,370 duplicates as opposed to 831. So we're going to go with the highly inefficient, unoptimized version of this algorithm because apparently it spanks my optimized version.
Okay.
So, but what we do have in the end is we've got three different hashes. We've got a 1D if you only need to send in an individual number. Again, this every time you send in the same seed number, you will get the same result.
Mm-hmm.
Same with all of these. Anytime you send in the same exact set of inputs, you will get the same result back out. But the trick is setting this up so that sequential numbers like 5 to 6 return a vastly different output. So it appears to be random, but it's all deterministic. So or pseudo-random as you will, but it is not a random number generator because this is not returning a sequence of numbers. We can't go and say, all right, give me hash 5, and then we get one number, and the next time we call it, we get a different random number.
Mm-hmm.
That's the stuff that we're going to be tackling in the next video.
Okay. Well, with that, then that will wrap up this section. Thanks a lot, guys.